Hi everybody, Patrick here from EngineeringShock.com and ElectronicLessons.com. Today I'm going to show off my new supercapacitor charger. It's a quad selection charger, meaning you can charge your capacitor to 2.5 volts or 2.7 volts or 5 volts or 5.4 volts. Actually, just under all of those voltages, because you never want to charge your supercapacitor right up to the rating. At least I don't. Now you can use for the 2.5 volt setting instead of 2.7 volt setting, you can merely place a capacitor in the terminal block labeled cap plus, cap minus, relative to the positive and negative of the supercapacitor, or you can use a series bank of two capacitors in series and place the negative of the bank in the cap minus and the positive of the bank in the cap plus terminals. So I'm going to use two 400 farad capacitors in series. They're rated for 2.7 volts each for a demonstration. Now I'll be selling this kit in kit form, assembled form. It will come with a 12 volt adapter, 12 volt 2 amp adapter, and certain listings will include some capacitors. I'll make a listing that actually has some capacitors as well, so you have everything you need to play with. In some listings I will just be selling the charger. So pay close attention if you're going to check us out at EngineeringShock.com or ElectronicLessons.com. So really, once it's built up, all you need to do is plug it in and press this button right here. You press it once, the LED blinks once, and you let go of the button. It'll charge to 2.5 volts, or roughly 2.42 volts. You press it and hold it into past when the first LED blinks. It'll blink once. You keep holding it, it'll blink twice. If you let go, then it will charge to 2.7 volts, or rather 2.62 volts roughly. If you keep holding it past, it'll go if one blink, then two blinks, then three blinks. You let go, 5 volts. If you hold it, one blink, two blink, three blink, 4 blink, you let go, it'll charge to 5.4 volts, or just under 5.4 volts. So what I'm going to do is I'm going to hook up a bank and I'm going to show you it charging. Now I want to add one more thing. This is a power resistor, and it is a beast, and it gets hot when you're charging. It actually says on the bottom of the PCB, I'm not sure if you can see it, it says warning hot. So be very careful, because touching it, it will hurt your finger. Something you got to keep in mind, because 12 volts is being dissipated across it, and 1.5 amps of current is being fed through it to the supercapacitor bank. So I'll plug in my supercapacitor bank and we'll charge it. So once this starts charging, and right now the bank is at 430 millivolts roughly. Once it's done charging, the relay clicks off and completely isolates the supercapacitor bank from the charger, so there's no back powering at all. Very happy with that aspect of the design. There's going to be 1.5 amps flowing into these capacitors. Lots of power really quick. So I've got my 12 volt adapter plugged into the bottom, plugs directly into the board. And I'm going to hold the button, and I'm going to show you what I meant by earlier with the LEDs. So once it blinks, if I let go now, it was 2.5 volts, now 2.7, now 5, now 5.4 if I let go now. So if you hold it too long, past the 4 blinks, you can let go and restart. So I'm going to wait, as soon as the LED blinks once, I'm going to charge it. I'm going to let go of the button instantly, and it's in charge to about 2.42 volts. Now you hear that click? Do you hear that click? That click is the relay turning on, and it'll take about a minute for this resistor down the left hand side to get really hot. But you can see this is a relatively big bank, and it's charging. You could use this in a supercapacitor flashlight if you wanted, for a really fast charge. I've designed it so that literally plug and play. You put this into your wall wart, and you press the button depending on your charge. If you have a single capacitor, you want to make sure that you follow the rating. So if you have a 2.5 volt capacitor, make sure you only let the LED blink once before letting go, or else you'll charge it past its maximum limit. Same with 2.7 volts. Those first two settings are meant for single capacitors only. And the 5 volt setting, 3 blinks, and the 5.4 volt setting, 4 blinks, are meant for 2 capacitors in series. Now, what you can also do if you want is you can use the test points that I'm using to probe with my multimeter. You can use those to splice off to your circuit. because those are isolated as well. They're isolated from the rest of the circuit, back powering. So you could add a booster onto those test points, a voltage booster, and a switch to basically use this as a supercapacitor battery. Now you see how fast it's charging. It's charging pretty darn quick. And my old supercapacitor charger kits, they charged I think they charged at 500 milliamps. So still fast, but not really fast. It would take more than a half an hour to charge. And as you can see right now, I've been talking for about a minute, and we're already up to 1.57 volts and climbing. So it's pretty fast. Now if I touch the resistor, yeah, it's hot now. It's so hot you don't want to touch it because it will burn you. You don't need to heat sink it because it's rated for the right power, but you want to be really, really careful not to burn yourself. Now I'm going to show you how to put one of these together once we're done doing the demonstration. We're going to put one together from scratch, just the kit itself, and we'll test it. I know it's a long video, and really I imagine that once we're done showing it off, you're not going to want to stick around unless you've actually purchased the kit. But you'll have that option in a little while. So what I'm going to do is I'm going to stop the video, and once we get closer to, say, 2.3 volts, I will resume so we can see what happens when it stops charging. So it's only been about a minute since we last talked, and once this gets up to just over 2.4 volts, that LED, the relay will click off, and that LED will start to blink, and it will continue to blink until I press the button again. There we go. So the instant loss off the capacitors is just the nature of the bank. They both have an instant. Capacitors usually have an instant discharge, and there's two of them. So that's actually they both only lost about 100 millivolts. Anyway, so I'll press the button. Now let's charge up to 2.7. Now you see how I let go after 2 blinks? So now it won't take us very long at all to get up to 2.7 because we're actually almost there. It depends on whether your capacitor is rated for 5.5 volts, 2.5 volts, or 2.7 volts. So I don't even need to bother pausing this because we'll be up to roughly 2.62 roughly volts, at which point the capacitor charger will turn off because we will have charged up to that point. Now if you had a single capacitor, oops, that actually knocked my multimeter off. If you had a single capacitor, that would actually not drop so much as soon as charging stopped. That's the nature of the series capacitor bank. These settings are meant for 2.5 and 2.7 volt capacitors singularly and out of bank. So anyway, I'll press the button to stop it, stop the blinking, reset the system, and I'll hold the button until we get 3 blinks. Let go. Now it'll charge up to just under 5 volts. The 2 capacitors in series. Now this will take a few minutes. It'll likely take about 3 or 4 minutes, maybe 5, at which point I will resume filming. I'd like to add, while you're charging, if you start fiddling around with the onboard electronics, especially near the chip, you could easily cause a false trigger by inducing tiny voltages coming from the human body. So we should be getting very close to trigger for our 5 volt setting. Again, it's set up to stop under 5 volts, so right around 4.9, I imagine. 4.91 maybe. There we go. And there's our instantaneous drop. So let's charge. Be careful, the resistor is hot. Very hot. So 1, 2, 1, 2, 3, 4. Wait a minute, I think that was, yeah. No, I put it to the 5 volt setting. Sorry, I got overzealous. 1, 2, 3, 4. Now we're on. Now we're talking. So now that'll bring us up to just under 5.4 volts, roughly 5.3 volts. You'll find that there's a curve, a timing. I mean, it's an RC circuit. There's a timing curve, and the higher the voltage gets here, the slower it starts to charge. Now it'll still charge very quickly, but you'll find that, say, charging between 0 and 2 volts will be a little bit faster than, say, 4 to 5.4 volts. But again, so I'm just going to, just to save some time, this video is going to run a little bit long because I'm actually going to assemble one in a minute. I'm just going to stop this, not 40 seconds later. So it should go off at around between 5.30 to 5.32. There are some reference resistors on board that have a tolerance of about 5%. Those reference the ADC on board on an analog to digital converter. And there we go. And we get our initial drop. So there we have it. So now your capacitors are charged. Now the resistor will remain extremely hot for about 15 minutes. Don't go near it. Don't go near it. When you assemble it on the board, it should be at least a centimeter above the board. Very, very, very hot. There are mounting holes so you can mount it. Even the bottom of the board is relatively warm. I wouldn't say it's hot, but it's warm. So, as well, I might add that the regulator gets kind of hot too. I could have heat sinked it, but it's not really necessary because it's still well within its limits to regulate 5 volts to the control circuitry. It just gets a little bit hot because you got 12 volts on it being dissipated, or sorry, right, you get 7 volts being dissipated down to 5 volts, which controls the digital circuitry. But anyway, blinking, stop blinking, reset. So now you unplug it. You got a capacitor bank that's ready to go. Just make sure that you're careful with this resistor because it is hot. Now you can mount that into a device. You got a portable battery. Takes about 5 minutes to charge down from 0 volts. There you have it. So let's build one. There is your standard kit. 5-volt adapter, 12 volts, a 2 amp adapter, which plugs directly into the board, and you've got your board, which we'll put together piece by piece right now. Custom PCB, where we'll mount everything. 5-volt relay, 2-pin terminal block, 3mm red LED, a 5K1 resistor, a 470 ohm resistor, 3 10K ohm resistors, a 100 microfarad electrolytic capacitor, a momentary push button, 3 power diodes, a 10 microfarad electrolytic capacitor, a 8 ohm 20 watt power resistor, 7805 5-volt regulator, a 0.1 microfarad ceramic capacitor, power jack, a 2N2222 transistor, and a program microcontroller / 8-pin dip socket. So let's place our resistors first. The resistors go here, 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 and here. R4 is labeled R4 5K1. Might be hard for you to see that here, but it's labeled right on the board. R3 is 10K, R3 10K. Our single 470 ohm resistor goes in the R2 slot, which is labeled 470R, R2. R5 is labeled 10K, so R5 10K. So our 3 10K resistors go in the R3, R5, and over here in the R6. R6 is also labeled R6 10K. So 470 is in R2 and 5K1 is in R1. Make sure you don't mix up those values. Very, 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 very important. The 470 ohm resistor limits current to the LED. The 5K1 resistor is a reference resistor, and the other 3 10Ks perform various different duties. So after you solder in your resistors, they aren't polarized. You can place them in either way as long as they go into the correct slots. Next, we will do the transistor and the capacitors. I'm feeling industrious, and I hope you are too. We're going to fit a bunch into this step. We're going to do the diodes, including the LED, the power diodes, the 2 electrolytic capacitors, the ceramic capacitor, and the transistor. So for the 2 electrolytics, you'll notice that there's a long leg and a short leg. In both cases, the Long leg is your positive, and your short lead is your negative. You got to keep that in mind. It is very important. Now, C3 right here, C3 labeled C3 100U for 100 micro, has a little tiny plus sign on the bottom here. So you want to make sure that your long lead is placed in the hole on the edge of the board, and that your short lead, your negative, is closer to where the regulator is going to be. Long lead on the bottom here, short lead here. If you reverse those, when you power the device on, that capacitor will pop, and it will certainly will not. It will cause problems for you. So look for the little plus sign on the bottom. In the case of C1, which is labeled 10U for 10 microfarads, the plus sign is also on the bottom from this perspective. So look for that little plus sign. Long lead in there, short lead on the upper side from this perspective, of course. Your ceramic capacitor, your 0.1 microfarad ceramic capacitor, is placed in the C2 slot right here, and it's labeled 0.1U, and it is not polarized. Both leads are the same size. You can place it in either way. No worries about it blowing up. Now the diodes. The diodes go in the D1, D3, and D2 slots. Now on the footprints, there's a white stripe on the upper hole here, white stripe on the footprint, white stripe on the footprint, and white stripe on the footprint. White stripe is an indicator of the cathode, the negative. Your diodes, if you look at them, have a white stripe on one side and black on the other. You want to make sure that from a bird's eye view, and this is very, very, very important, that from a bird's eye view, the white stripes on the diodes face the side with the white stripes on the board. If you, in every single case, if you reverse any one of those diodes, you're going to cause huge problems in your circuit. Short circuits, resets. You have to make sure that they're in the right polarity. So in the case of D3 and D1, the white stripes on the board are facing each other on the upper side of the board, whereas the opposite side of the white is on the lower side of the board. So make sure that from a bird's eye view, the white stripe is facing up on both of these footprints. Solder them into place, give a healthy amount of solder. In the case of D2, the white stripe, which if you purchase this kit you'll see on the bottom here, is facing the right side of the board, and the left side is where you'll place your black side. Black side, by the way, is anode, which is positive. Be very, 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 very careful. Lastly, or rather, second lastly, the LED. Similar to the electrolytic capacitors, the LED has a short lead and a long lead. Same thing. Long lead anode, short lead cathode. Long lead positive, short lead negative. And that was actually placed in the LED slot right here. Now, the best way to, there's another way of determining which side is positive and negative, but just take my word for it. The negative is the right side with the actual LED indicator labeled LED. You want to place your short lead from this perspective in the right hole, and your long lead in the left hole. Reverse that. You won't harm your circuit, but your LED indicator will not work, and as we've all seen, that's very pivotal to the operation. So let's solder those into place. Good solder joints, no shorting. And lastly, we'll do the transistor, lastly for this step. Now the transistor has a flat side with writing on it, and it has a curved side. As you can see, it's wobbling on the curved side. The T1 slot right here, it's labeled T1, 2N, 2222. It's actually not labeled that, it's labeled 2N 3565, or 3965. It's actually a 2N 2222. It's an NPN transistor. Now, on the board, there's a curved side facing the left and a flat side of the footprint facing the right, facing C1. Make sure that from a bird's eye view, the flat side with the rating on it is facing the capacitor C1, and that the curved side of the transistor is facing the left-hand side of the board from a bird's eye view. Very, very important. Otherwise, your relay circuit will not trigger. It will not turn on or off if you reverse that transistor. So, solder all those into place. Good solder joints, no shorts. Next, we will do our DC jack, our socket, our button, and our terminal block. This is another step where we'll actually be doing a lot in one step. Your button has 4 pins on it, and it fits in the cell slot right in the middle here. It's a 4-pin momentary push switch. It really only fits in one way. 2 pins on the right, 2 pins on the left. It should pop into place. Line up the holes, pop into place. Make sure that it's flush to the board when you solder it into place. Very easy. Your regulator has a black side with writing on it, and it has a white side, which is essentially ground. The 7805 footprint right here has a white backing, simulating ground. So make sure that when you place it in from this perspective that you have the black side, the front side with the writing on it, facing the bottom of the board from this perspective. Your DC power jack, 3 pins, really only fits in one way. The hole is facing the bottom of the board. When you solder that into place, don't go overboard. You don't want to melt the plastic. Just make sure that there's a healthy amount of solder on each one and that it flows. But do it gently. If you're not having a lot of luck doing it slowly, just do it slowly so that you give it time so that you don't actually burn the DC power jack. It's difficult to burn it, but I've seen it before if you apply too much heat too fast. So, do one solder joint at a time. Even if you don't fill the gap, you don't need to fill the entire gap. Just make sure you make the connection, all 3 connections. Your terminal block goes right here, and you want to make sure that the terminal sides are facing out, so facing the right side of the board. The terminals have a plastic side and a terminal side. Make sure that the terminal side is facing outward so that you can actually wire in your capacitors. Otherwise, the terminals will be facing the capacitors and you'll never get anything wired up. And it is difficult to desolder. Lastly, your socket. The socket is placed in the IC2 slot right here. Now, on the footprint, the left side of the IC2 slot has a notch in it. On the left side of the socket, there is a notch in it. It might be difficult for you guys to see, but on the left side of the microcontroller, there is a notch in it. Left side. Make sure that from a bird's eye view, all of those notches line up. In this case, the notch on the chip is facing the left side of the board from this perspective. If you reverse that chip, you power it on. Goodbye chip, goodbye project. Now, if that does happen, you can always order another chip, but you don't want to make that mistake. Line up the notches. Left-hand side, left-hand side, left-hand side, notch on the left-hand side. And once you start in the place your microcontroller with the notch on the left-hand side from this perspective. Once we're done that, we will do our last step, which will be our 5-volt relay and our power resistor. Okay, so last step, relay, 5 pins, 3 on one side, 2 on the other. It goes right in this relay slot. Only fits in one way. Should pop right in. And make sure that there are healthy solder joints on all 5 holes. Make sure it's flush to the board. Lastly, your power resistor. You might notice that I folded one side in a little bit, and one side is almost right on the edge. That's because you want to make sure that you're not obstructing this capacitor, the 100 microfarad capacitor, when you place it in. You also want to have it about as close as you can as far as you can off the board as humanly possible. So, from this view, hopefully you can see it. Fits in. Yep, there we go. And you just want to make sure that it's placed a little bit further away from the capacitor as you can. It'll come off the side of the board like this. And when you're soldering it, just make sure that that wire right there isn't shorting against anything, especially the back of the regulator, because that'll be a direct short to ground. So once you solder it into place, you can actually move it around a little bit. It's good to even keep it a little bit further away from the microcontroller, so off to the left of the board, maybe like that. But it really is up to you. Just remember, it gets hot. It gets hot, it gets hot, it gets hot. Don't short that wire. Keep it away from the board, it gets hot. So solder it into place, and we'll run a couple tests. Now that we're done, test number 1. Take your line, your power supply, plug it in, and don't put a capacitor on the output. Just press the button once, relay turned on and off, and it blinks. Now that happens because it detects that there's no capacitor there. Press the button, test again. You can still go up to 5.4 volts. It won't matter. On, off. So that's just a safety. It's obviously, even if it was unloaded, it wouldn't charge, but there's a cap detection setting in there. So let's charge a single capacitor as opposed to a bank set. Okay, I've got a single 50 farad 2.7 volt capacitor tightened into the cap plus to the positive and ground to the negative of the single capacitor. So let's charge it to 2.7 volts. See how fast it charges. Look at that capacitor fly. Now, as you see there, it's only going to take a minute or two to charge at best. We're charging at, I'd say, 100 millivolts per 2 seconds right now, 2 or 3 seconds. Really quick. So I'm just gonna let that charge. I don't think I should waste your time. This will be the end of the video once this charges, but I just wanted to show you this, so I'm gonna stop the video for about 20 seconds. So plug it in, have yourself a bathroom break, come back, should be charged. There you go. It brought about 2.6 volts, and actually the refresh rate on this thing isn't all that great, so I'll stop it, and there you go. So, thanks for watching, everybody. This can be found at engineeringshock.com and electroniclessons.com. It will be in kit form. One version will have just the module/kit with the 12-volt supply, wall wart rather, and I'll have another listing that has a set of 2 400 farad capacitors. So, hopefully this sparked your interest. For those of you who are actually still watching, thank you. I don't expect many people who have made it this far. Take care and have a great day, everyone.